So that means we has to store this data. So we have to store this data so that the microprocessor will get the data from that storage and it will process the operation. So it will do that particular operation. So this is the reason. So some memory device is required along with a microprocessor. So we require some memory to get interfaced with this microprocessor. So without memory we cannot do some operations using this microprocessor. So whenever the user provides the data to the microprocessor, the data has to be stored in a particular memory location. So that's why we require some memory. So memory is nothing but some space which used to store this data. Okay. So this is why we need to interface this memory with this microprocessor. So without memory interfacing, we cannot store the data in the on which we want to operate. So memory interfacing is considered as the integral part of computers. So we have to now see about how the RAM and ROM get interfaced with 8086. So let me explain you about the memory device. I have explained it yesterday, but just let me recall it. So let's consider a memory device. So let's consider a memory device. This device will have some address lines. So we have some address lines and we have output lines. We have some input output lines. Input output lines and some address. So this memory device will have address lines and input output lines. So through these address lines, we will connect a microprocessor to this device. So the microprocessor will get interfaced with this memory device by these address lines. So the microprocessor also contains some address and data lines which are multiplexed and separate address lines. So you have separate 4 address lines and 16 multiplexed address data lines. Okay. So these data lines and address with this and so we want to interface, excuse me, and microprocessor need to the memory device. The address lines are to use make the okay. Here we have some input output based on the memory device. Based on the of memory device, this input will be provided. So some devices will have separate input lines and separate output lines. So if you consider this as a memory device, so this memory device has separate lines for input and separate lines for output. These lines will used as input lines and this will be used as output lines. But for some type memory devices, so let's say this is a memory input lines are the direction of output lines will be used to indicate both in on this. So it is used to indicate both input and output on this. So on the of the device output line and based on the capacity. So capacity device not provided. So this is provided the capacity of memory device. The memory device is capacity of the one so that can okay. So the capacity so capacity is
Ma'am, voice
we
break
use
అవుతుంది ma'am.
T at this time. So is it audible now? ఇప్పుడు
బ్రేక్ అవుతుంది మ్యామ్.
సో ఇప్పుడు డిస్టర్బెన్సెస్ ఎలా ఉన్నాయా? కెన్ యూ ఏబుల్ టు హియర్?
Yes ma'am.
Okay. So the capacity of the memory will determine the number of address lines. So we are talking about memory interfacing using RAMs and ROMs. Okay, interfacing using RAMs and ROM. Okay, so let's see what is the basic what are the basic steps involving in this interfacing concept. Okay, so if you see, this RAM and ROM are semiconductor memories. What are these? Semiconductor memories. Okay, so RAM and ROM are semiconductor memories. So these RAMs are categorized into static RAM, dynamic RAM, and SD RAMs. So ROMs are categorized into EPROMs, EEPROMs, different categories. We have different categories of memories. I have already explained you: SRAM, DRAM, EPROM, EEPROM, EAROM. So electrically alterable read-only memory. So you have different types of RAMs and ROMs available. So these semiconductor memories are organized as two-dimensional arrays of memory locations. So if you can see, so these memories are arranged wise. So these are arranged as two-dimensional arrays of memory locations. Two-dimensional arrays of memory locations. So how these memories are arranged? These semiconductor memories are arranged as two-dimensional arrays of. So we have different memory locations here in a row. So this is called as array of memory location. So this is called as another array of memory location, and this is one array of memory location. So that means so these are all two-dimensional. So we are not considering it as three-dimensional location. Two-dimensional location. Okay. So these are all whatever the semiconductor memories we are having. These are all organized as two-dimensional arrays of memory location. So these are all two-dimensional arrays of memory location. So let us consider 4K by 8. So this is the size of the memory. Okay. So let's consider 4K by 8 memory block. Okay, so we'll consider a 4K by 8 memory chip. So here the 4K will indicate the capacity of the memory. So this is capacity of memory chip. So what is the indication of 4K? 4K will indicate the capacity of memory chip. Okay, so 1K memory chip contains 1024 memory locations. 1K memory chip contains 1024 memory locations. So likewise 4K memory chip contains 4096 memory locations. Okay, how many memory locations it contains? This 4K memory block contains 4096 memory locations. Okay, so this 4096 memory location here by 8. So this 8 indicates number of bits. So that means each memory location is capable of storing 8 bits. Okay, so each memory location is capable of storing 8 bits. That means where each location contains 8 bits of data. So only if you consider any one memory locations out of this 4096. So these are let's say these are 4096 memory locations. So if you consider any one memory location out of this 4096 memory locations, it can accommodate 8-bit data. So if you consider this memory location, so it also can accommodate 8-bit data. So here 4K by 8, 4K indicates the capacity of memory chip, and 8 indicates the number of bits each memory location can accommodate. Okay, so let's now consider a 4K by 8 memory block. Okay, so now we are considering a 4K by 8 memory block, and in this 4K by 8 memory block, this 4K, so the capacity of number of memory locations is 4096. So this is block contains 4096 memory location, and each block can accommodate 8 bits of data. Okay, each location can accommodate 8 bits of data. So now we are considering this. So if you can see, it's obviously the addressing required for this 4K. So number of address lines required for this 4K type of memory is 12. So we will require at least 12. So we have to accommodate at least 12 address lines for this 4K memory. So how these address lines? I'm saying that for 4K memory we have to provide 12 address lines. How these address lines? How this 12 we can get? So that means, so let's say we have n memory locations, okay? So just say this 4096 is n, so capital N. So we have n memory locations for this memory chip. So whatever the memory chip we are considering, so that memory chip contains n memory locations, and small n be the number of address lines. So number of address lines required. So number of address lines required for this is small n. So capital N is the number of memory locations. So it indicates the number of memory locations that a memory block can accommodate, and n is the number of address lines required. So this n, we can get this number of address lines as log n to the base 2. So how can we can get this number of address lines? So that means log n to the base 2. The number of address lines required for a particular memory block will be defined as n is equals to log capital N. So where capital N is the number of memory locations and small n is the number of address lines. So this is how we can get the number of address lines. So here it can be written as n is equals to, we can write n is equals to 2 power small n. So we can write this as, by applying natural logarithms, 2 power n. So capital N is equals to 2 power small n. So here we have capital N is equals to 4096. So 2 power 13. So 13, 2 power 13 value is 4096. That means we require 13 memory locations. That's what So we require 13 memory locations. Previously, I said that it is 12, but it is 13 memory locations required for this 4K byte of memory. So this, how can we find out this number of address lines required? So likewise, clear? Address lines ఎలా find out చేయాలో అర్థమైందా? So if a memory block contains, whatever the memory chip we are considering, it contains some memory locations. For here we are considering 4K memory block. So for this 4K memory block we have 4096 memory locations which will be indicated by capital N. So capital N is equals to 4096. So let small n be the number of address lines required. So number of address lines required. So we can find this address lines as n is equals to log n to the base 2. So by using this relation, we can get the number of address lines required for 4K by 8 type of memory chip. For this memory chip, how many address lines required? So that will be, we can get that relation, that thing by this relation. So the number of address lines required for this 4K by 8 memory will be given by this relation, n is equals to log capital N to the base 2, where small n will be the number of address lines required and capital N will be the number of memory locations. So by simplifying this, nothing but applying anti-logarithms, so we can get n is equals to 2 power small n. Okay? 2 power small n. So we have 4096 memory location equal to 2 power small n. So this is 2 power 13 equal to 2 power n. So here bases are equal, exponents must be equal. So small n is equals to 13. So that means we require, we have to consider 13 address lines for 4K by 8 type of memory chip. Okay. So this is how you have to find out the number of number of address lines. ఓకేనా, అర్థమైందా?
Yes, ma'am.
Hello. Okay. So now, so we have n memory locations. So total you have n memory locations. So we have to interface this n memory location chip, that means 4K by 8 chip to 8086 microprocessor. So we have to connect these two. We have to interface a 4K by 8 RAM to 8086 microprocessor. So in order to make the interfacing possible, first we have to make sure that how many memory locations we want to interface. That means we must make sure that how many memory locations has to be interfaced with 8086. So we are interfacing some number of memory locations with 8086 means, that means we are providing a permission. We are giving a permission for this 8086 to access all the memory locations. So whatever the memory locations we are interfaced with this 8086, the 8086 can access all the interfaced memory locations. So here we have capital and memory locations, out of which I want to interface P locations. Okay, so I want to interface some P locations out of this capital and locations. So total locations I are having is capital N. So capital location, total locations are capital N. Sorry for the inconvenience. So here we are having total of n memory locations, and I want to interface p locations out of this total and memory locations. So my total locations are n, and I want to interface p locations. So the remaining locations I don't want to interface is n minus p. Okay, so totally I have n location and I want to interface p locations. My remaining locations are n minus p. So I want to interface only p locations out of this n. Is what I want location. So at least three address lines out of the available address lines can be has to be connected directly to the memory and this microprocessor. So I have some address lines, right? I have 13 address lines. Out of this address line, I have to use this p many number of lines. So I want to use these p lines out of n lines. That means I have to use some of the address lines in order to interface. So in order to get interface these p lines, I have to use some address lines. So however, uh, out of n locations, only p locations are to be interfaced. Then at least significant p address lines, that means significant p address lines out of the available address lines can be directly connected from this memory locations to the microprocessor. So out of this 13 some address lines, I have to use some address lines to connect these P locations to 8086. So using address lines only, we are interfacing this memory device with this microprocessor. The interfacing will be done by connecting the address lines only. So I have 13 address lines for this n memory locations, and I am interfacing P memory locations. So significant P address lines, that means the number of address lines used for connecting these P locations to this 8086. I don't know the number of address lines. So, but significant P address lines are to be used. That means all the P locations has to be connected to this 8086. So I have chosen P locations, and all the P locations has to be connected with 8086. So significant P address lines are to be used. That means some address lines which can connect all the P locations to 8086 I have to use. Okay. So then the remaining are n minus p locations. So the remaining are n minus p locations. These are called as higher order address lines. So some address lines are used for connecting purpose. These are called as lower order address lines. address lines, and I'm not connecting all the n memory locations. For n memory locations, I need 13 address lines, but I'm not connecting all the n locations. I'm only interfacing p lines. So I have to use some of the address lines. I will not use all the address lines for interfacing. I can use only some of the address lines which can be required for connecting all these p locations to this microprocessor. So these address lines which I need to use for interfacing these P lines with 8086 are called as lower order address lines. Suppose I am using 7 address lines for connecting all the P locations to 8086. So these 7 are called as, so this is not the value, exact value, I am considering it for rough, okay. So roughly I am using 7 address lines. So that means these 7 address lines are called as lower order address lines. Okay. Remaining 6 will called as higher order address lines. So that means the address lines which are used to indicate this n minus p locations. So this n minus p locations ni indicate చేయడానికి ఏవైతే రిమైనింగ్ అడ్రస్ లైన్స్ ఉంటాయో ఆ లైన్స్ ని మనం ఏమంటామమ్మా హయ్యర్ ఆర్డర్ address lines. Okay, clear about lower order and higher order address lines. So out of the available address lines, so if I want to interface some p locations to this 8086, so n locations ఉన్నాయి అందులో p locations ని మాత్రమే నేను ఇంటర్ఫేస్ చేయాలనుకుంటున్నాను. That means I am only providing the access of only these p locations to this 8086. సో ఈ p locations ఏదైతే యాక్సెస్ ప్రొవైడ్ చేస్తాను అని నేను అనుకుంటున్నానో వాటిని మాత్రం కొన్ని అడ్రస్ లైన్స్ ని యూజ్ చేసుకొని కనెక్ట్ చేస్తాం. సో అవుట్ ఆఫ్ 13 is my address lines required for all the n memory locations. So but I will not use all the 13 address lines to accommodate only p locations. Since n minus p, I am left with n minus p memory locations which are not interfaced. So these n minus p are not interfaced memory locations. So they are not non-interfaced memory locations. Only p locations are interfaced. So the remaining n minus p are non-interfaced. So this p for all the I have 13 address lines. So for all the n locations, I need 13 address lines, but I'm using only p locations for interfacing. So for this particular p locations, I need some significant p number of address lines. So whatever, how many address lines required for interfacing, those are called as significant p address lines. So those address which are used to interface locations to address line. Okay. So and the remaining address lines which are used to support p locations are not interfaced, they are called as high order. Clear? ఇక్కడ వరకు అర్థమైందా?
Yes, ma'am.
For the address lines will be called as address decoding lines. Address decoding lines. That means these higher order lines are called as address decoding lines. These will be connected to chip select pin of memory device. Okay. So memory device. So based on the chip select pin only. So let's say this is your memory device. It contains some address lines. It contains some input output lines. So this is memory device. So it contains a pin called chip select. Okay. So a pin called chip select will be there. So read by write bar. So this is your another pin. So and it contains some memory locations. Okay. So this based on this bar only. Based on this set bar only, you can say that the microprocessor and this memory device getting microprocessor. So based on the log present on select pin only, we can say that is there any connection between, is there any memory device and the microprocessor. Okay, so if its logic is high, so logic is high means chip select bar. So chip select bar is that is equal to 1. So name
మేడం వాయిస్ బ్రేక్ అవుతుంది మేడం.
0 is the logic. Chip select bar 0 is the here with now. Hello. Hello, hello.
No, ma'am, break అవుతుంది ma'am.
So now it audible. Hello. I'm audible. Hello.
Yes, ma'am.
Hello. Okay. So here everything, that means the communication is microprocessor and integrated by this chip. Whether the memory device or so that will be by this chip select in only. So if the chip select is high state, so that CS, so C bar should be 0. So the logic is 0. So this is equal to, so we to if you true state, then CS should be at 0. That activating logic state is when C bar is 0. So on this condition only, so there we have the memory and information or data will be explained. This bar is at logic. So that is at 0. Then only this microprocessor will the it is logic 1. C logic 1. So that means low logic. So there will be no active interaction between microprocessor and memory device. So is these two connected physically. So there is physical connection between microprocessor and memory device. So the microprocessor is not allowed to access the micro, not allowed to access the memory, the connection between these two devices. This microprocessor and memory device. So the microprocessor will not location of device. Okay, when it selects the one, so when it is logic, low that device bar is location between memory device and processor. So the type operation and the entire accessing of this processor to this memory chip will be based on this chip selecting. Okay, whatever the order address means lines are not used for interfacing. So the address for these lines will be used to from the line used to select the chip. Okay. Yeah. Like what are the steps involved in connecting the, what are the steps involved in interfacing? So first of all, we have to consider a memory chip. So I am considering a 4K by 8 memory chip. So this contains some 4096 memory locations, which is equals to capital N. So that means the capital N will indicate the memory location memory chip. This is the memory chip diagram, and 4K indicates the of the memory chip. This indicates capacity of memory. Each 8 indicates the number of bits, the number of bits each memory location can accommodate. Each memory location of chip can accommodate. Okay. So first of all, we are considering available memory chip. We are considering 4096 memory location. So what are these memory locations? So memory locations indicated by variable n. So n indicates the number of memory locations. So first we are considering a memory chip, and we are uh, creating a number of locations, and number of the capacity of the capacity of the and the memory the chip contain. So now we are considering a 4K by 8. So this 8 indicates the number of bits each memory location can accommodate. So if you can consider any of the memory location, so under this chip, if you can consider any of the memory location, each location can accommodate 8-bit data. So each location can accommodate 8-bit data. So first of all, we have to arrange the available memory chip so that it can obtain a 16-bit data bus width. Okay, so we have to see that it contains a 16-bit data bus width. So that means this is only 8 bits. So the data bus range is 8 bits. So in order to accommodate a 16-bit data bus, since the microprocessor contains 16-bit data bus, the memory chip we are considering has to be also accommodate 16-bit data bus. So what is this bus? Data bus. So this can be able to this can be capable of a 16-bit data bus. So we have to obtain a 16-bit data bus for this memory location. So how can we obtain? So we have to connect two memory chips in parallel. Two memory chips in parallel. So if you can consider two memory chips in parallel, so then it can accommodate a 16-bit data bus. Okay. So if you consider a RAM, so you have to consider two RAMs in parallel. So if you can consider two RAMs in parallel, so then these two RAMs can provide, so this can provide an 8-bit data bus and this can provide an 8-bit data bus. Total we have a 16-bit data bus. So while interfacing with 8086, so this is 8086 microprocessor, in order to consider an 8086 with a memory chip, so we have to consider the memory chip in such a way that it can accommodate a 16-bit data bus. Okay, so first we have to arrange the available memory chip so as to obtain a 16-bit data bus. So arranging is nothing but we have to consider the chips in parallel. Okay, so if you consider two chips in parallel, so since each chip can accommodate a 8-bit data, these two chips will collectively can accommodate a 16-bit data bus. Okay, so first of all you have to memory chip so that we can obtain a 16-bit data bus width. Okay, so the upper 8-bit is called as even address. Okay, so the upper 8-bit is called as even address bank. Even address bank. And the lower 8-bit is called as odd address bank. So even address bank and odd address bank. So the upper 8-bit is called as even address bank and lower 8-bit is called as odd address memory bank. Okay, so upper and lower. So sorry, the upper is as odd address memory bank and lower is called as even address memory bank. So that means D0 to D7 is called as even address memory bank, and D8 to D16 is called as odd address memory bank. So you have we have arranged the memory chip so as to contain 16-bit data bus. So has to obtain 16-bit data bus. So the upper address is called as odd address memory bank, and the lower address is called as even address memory bank. So when I am explaining about something called memory segmentation in first unit, I have explained you this. So the entire memory will be considered into divided into two parts. One is odd address bank, and next one is address bank. So this the assigning of data into this memory will depend upon BHE bar and A naught signals. So you have BHE bar signal and A naught signals in the pin description of 8086. Pin description of 8086. So I have explained you this memory segmentation concept while I am explaining first unit concepts. So the entire memory available in the microprocessor divided into two banks, odd address bank and even address bank. So this the allocation of memory into these particular banks will be depend upon this BHE bar and A naught pins. So we have discussed about these pins in pin description. You can recall the states from the pin description. Okay, so the entire available memory we have to consider it in two portions. Okay, so one is address bank and another one is odd address bank. So the even address bank is nothing but the lower 8 bits of the address. So the upper 8 bits is called as odd address memory bank. So we have to first arrange the available memory chip so as to get a 16-bit data bus. Under the 16 bits, the upper 8 bit is called as odd address memory bank and lower 8 bits is called as even address memory bank. Okay. So next we have to connect the memory address lines of this memory chip with the microprocessor chip. Okay. So whatever the address lines. So whatever the address lines present in this memory chip will be connected to this 8086 processor. Okay, so we have to connect the address lines of this memory chip with 8086 processor. So next we have to connect the read and write commands. RD bar and WR, we are having these commands. So and we have to establish the connections in between this read and write commands. Okay. So first of all, we have to arrange the available memory chip so as to obtain a 16-bit data bus. So after getting this 16-bit data bus, nothing but we have to arrange this memory in parallel. So we have to arrange two RAMs in parallel so that we can get a 16-bit data bus. So the upper 8-bit is called as odd address bank and the lower 8-bit is called as even address bank. So whatever the address lines present in these two memory chips, so which are considered as a single chip here. So these chips, whatever the address lines we are having, those address lines are to be get connected with 8086. Okay. And next thing, you have to connect the read and write commands of 8086. So these are called as signals. So the signals will be initiated by 8086 so as to get the access. So if you want to get the access between these two, the signal read bar and write bar are to be initiated by this microprocessor. Clear?
Yes, ma'am.
అర్థమైందా? Okay. So now we have to connect 16-bit data bus of this memory to the 16-bit address data lines of 8086. Here we have 16-bit data lines which are multiplexed with address lines. Okay. So we have 20 address lines and 16 data lines. So the 16 data lines are multiplexed with address data lines. So we have address and data lines combinedly for 16 address lines and 16 data lines are combined. So that those are multiplexed address data lines, and the remaining 4 address lines we have a combined 4 address lines with status pins. So later this the remaining 10 address lines are multiplexed in the case of 8086. So whatever the 16 address data lines present in this 8086 will now connected to the 16 data lines of this memory bank. So this memory bank contains 16 data lines. So we have created a memory bank in such a way that it can accommodate 16 data lines. So whatever the 16 data lines present in this memory bank has to be connected with this 16 address data lines of the microprocessor. So the 16-bit data bus of the memory bank has to be connected with address data lines of the microprocessor. So next we have remaining address lines, right? So we have remaining address lines. So these remaining 4 address lines of the microprocessor, including with BHE bar and A naught bar. So we have another two commands, BHE and A naught. So these are used to indicate the memory banks. Okay, so these are used to indicate the memory banks. So remaining 4 address lines and these two command lines. Okay, so including with these two command lines and the 4 addressing lines of the microprocessor are used for decoding purpose. Okay, so decoding purpose is nothing but in order to control the chip select pin. Okay, in order to control the chip select pin of memory bank. Okay, so in order to control the chip select pin for odd and even address memory bank. So based on this chip select pin only, this odd and memory bank will get accessed with 8086. So that's what I have already explained. So based on the chip select pin only, this memory banks will get there is an access for this memory banks to this microprocessor. Okay, so the microprocessor can access this memory bank only the chip select bar is at logic 0. So in order to control the this chip select pin of the memory bank, so this remaining address lines and the BHE and A naught are used. Okay, so the remaining 4 address lines of 8086 along with BHE bar and A naught are used for decoding the required chip select pins for odd and even memory address banks. Okay, అర్థమైందా?
Yes, ma'am.
So now let's draw the diagram. So you have 15 more minutes. So these are the steps. So first we have to consider the memory banks, and you have to make each memory bank can accommodate a 16-bit data bus. So in order to make the memory bank to address a 16-bit data bus, we have to consider 2 RAMs or 2 ROM chips. Okay, since each RAM can have a capacity of 8-bit. So in order to provide a 16-bit, we can arrange 2 RAMs or ROM devices in parallel to each other. So next we have to connect the address lines. So you have to connect the address lines of the chip with the microprocessor, and we also have to connect the read and write commands of this read and write signals of this memory chip and microprocessor. So the next step is to connect the 16-bit data lines of this memory bank to 16-bit address data lines of 8086. So next you have to connect this 16-bit data bus to 16-bit data lines. Okay, so the remaining address lines of the microprocessor along with BHE bar and A naught bar will provide you the will act as a decoder. So the remaining 4 address lines and BHE bar, A naught bar will act as a decoder instructions to this decoding network. So we use a decoder also. So decoder. So we use a decoder also. This decoder, the signals will activate this decoder. Okay, so this decoder will get activated by this remaining 4 lines and BHE bar and A naught bar. So that means the remaining address lines of the microprocessor along with BHE bar and A naught bar are used for decoding the required chip select of memory bank. Okay, so either even address bank or odd address bank that will be indicated here. So now let's draw the entire circuit. So first we have a So you have to use two RAMs or two ROMs. So let's see how. So let me explain. I am interfacing a 4K by 8, two 4K by 8 RAMs and two 4K by 8 ROMs, two 4K by 8 RAMs, two 4K by 8 ROMs. So I'm considering two 4K by 8 RAMs and two 4K by 8 ROMs, and I am now making a interfacing circuit. So I'm now developing an interfacing circuit. So first of all, I need two RAMs. So I have two RAMs. So this is one RAM. So two ROMs. So this is one ROM and this is another ROM, and two RAMs. So this is one RAM and this is another RAM. So I am now considering two ROMs and two RAMs, two 4K by 8 ROMs and two 4K by 8 RAMs. Why I am considering two? So since I have to provide a 16-bit data bus, so I have to provide a 16-bit data bus. So I require two RAMs or two ROMs for one memory bank. So this is one memory bank and this is another memory bank. First of all, this RAM contains A0 to 11, A0 to 11. So it contains 12 address lines of minimum. So the 12 address lines are connected. So first I have to connect the address lines of memory banks. So memory devices. So these are the memory chips. So first I have to connect the address lines of the memory chips. So I'm establishing the connection between these address lines of memory chips. Okay. So next, so I have to connect this to the address lines of processor. So I have to connect this to the address lines of the processor. Okay, so let's say this is connected to the address lines of the processor. So the upper 8 bit is called as odd address bank and lower 8 bit is called as even address bank. So this is your odd address bank and this is your even address bank. So I am considering this as the even address bank. That means the data lines will be D0 to D7. Since it is a low even address bank, so the data lines will be D0 to D7. So this is higher address bank, sorry, odd address bank. So this is the data lines will be D8 to D15. So here the data lines will be D8 to D15. Okay, so this is higher address bank. So since I am calling it as odd address bank, so this contains higher data lines, higher bits of data lines, and this is even address bank. So this contains lower lines of data lines. Okay, so this is how we have considered two memory banks. One is ROM bank and one is RAM bank. So we have to use a signal called OE bar, so which is called as output enable. Okay, so where we can get this output means we can get this output from decoder circuit. So whatever the address lines BHE bar and A naught. So by using these lines we will get the signals from decoder. So we will get the signals from the decoder. So I have to consider a decoder. So here I am considering a decoder. So here I am using BHE bar. So next A0, A1. So A0 is the address pin and A1 is the address pin. Okay. So I am considering this A0, A1, A2 lines. And now this is a 3 to 8 decoder. So since I am using 3 inputs, I have to get 8 outputs. 3 to 8 decoder. So 0, 1, 2, 3, 4, 5, 6, 7. So total 8 outputs. So I am using a 3 to 8 decoder in which I am considering E1, E2, E3 are the things which are used for logic generation. Okay. So I'm using these pins for logic generation of address lines A0 to A15. Okay. So these are the total address lines. Okay. So I'm using 16 address lines. Up to where I'm using already 12 address lines, I have to connect this to this end. Here and here I'm using 12 address lines. The remaining 4 will be used for CS signals. Okay, so the remaining lines will be used for CS signals. So here CS1, CS2, CS3 and CS4. Okay, so I'm using CS bar 1, CS bar 2, CS bar 3 and CS bar 4. So the remaining lines will be connected to the CS bars. Okay, clear. So next I have memory read and write pins. So memory read, memory write. So again here also I have memory read and memory write. So memory read, memory write pins, memory write. So these pins will be connected to read and write of 8086. I have to connect these pins to read and write of 8086. Okay. So this is how we have to do the interfacing. So we have to do the interfacing likewise. First of all, we have to connect the. So what are the steps? So we have to arrange the available memory of the chip. So we have to arrange the available memory of the chip. So that means the memory of the chip is arranged so that we have to get a 16-bit data bus. So first of all, we have to arrange the available memory chip so that we can get a 16-bit data bus. Since I am considering a 4K by 8 memory type, so 4K by 8 memory type can accommodate only 8 bits in a particular memory location. So it contains only 8-bit data bus. So it contains only 8-bit data bus. So I have considered two 4K by 8 memory locations under a memory bank. So under a memory bank, I have considered two 4K by 8 memory locations. Okay. So I have arranged these available memory chips so that I can obtain a 16-bit data bus here. So here the combination of these two data buses will be a 16-bit data bus. Okay. So first step, first step we have to fulfill the steps here. So I am connecting 16 data lines. So we have to use 16 address bus in order to connect these 16 lines. So that is the first step because I have to use 16-bit data bus memory bank, okay, memory chip. Okay, so this is the memory bank. So I have used two memory chips here. So one will be 4K by 8 and another will be 4K by 8. So each chip contains 8-bit data bus. So when I am using this in parallel, so if I use these two 8-bit data buses in parallel, I can get a 16-bit data bus. Okay. So after getting this 16-bit data bus, I have to connect the address lines. So here I have 12 address lines for this 8-bit bank and 12 address lines for this 8-bit bank. So these two lines of, these two address lines, these 12 and these 12 need to get connect the address lines. So I am connecting the address lines to the address lines of the processor. Okay. So connect the memory address lines of the memory chip with those of the microprocessor. So I am connecting to this microprocessor. So next we have to connect the read and write commands. So that means here we are having memory read and write commands in the memory bank. So these memory read and write commands are connected to the read comma write commands of the processor, 8086 processor. So next thing, so whatever the data bus I have provided, so these two memory bank, and under this memory bank I have 16 data lines. So these 16 data lines I have to consider it as odd address and even address. The upper 8-bit is called as odd address and the lower 8-bit is called as even address. The overall 16 data lines I have to connect it to the address data lines of 8086 processor. So I'm connecting it to the address data lines of the processor. So remaining I have 4 address lines. 4 address lines for 8086. So total 20 address lines. 8086 contains total 20 address lines. 16 are multiplexed with data. So 16 are address data lines and remaining 4 are address status lines. So remaining 4 address lines I have to connect it to sorry, I have to use these address lines along with DHE bar comma A naught. So these are the signals of 8086. So which are used to define the memory bank. So define the address of the memory bank. So even the data has to be stored in even bank, or the data has to be stored in odd bank. So that will be given by the signals. Okay. So along with these four address lines, these signals and these four address lines will be used as decoding purpose. Okay. So these are used for decoding the chip select pin. Okay. So what is the purpose of this decoder? So this decoder will be used to activate this chip select pin for odd address bank or get address bank. So the structure of the memory derive this decoding circuit. So this decoding circuit is used to drive this memory. Sorry. So this decoding circuit is used to drive the memory chip. Sorry, chip select pin of memory bank. Okay. So this is how you have to do the interfacing of a memory circuit in 8086. So the entire diagram two memory banks, two RAMs, two RAMs and two ROMs. Address lines are connected. So both the address lines are connected to address lines of 8086. Next, both the data lines are connected to the multiple lines. So the remaining address lines along with this DHC will be used for this decoding circuit. So this is a 3 to 8 decoder. So the decoder will be used to drive the CS pin. So here you have CS pin driven by this line. So in order the service, so the address may memory bank continue the address. This is how I use facing such. So how we have mapping continue discuss in the next class. Okay, clear for today? అర్థమైందా?
Yes, ma'am.
Hello. Okay. Let's consider